Hey everyone, and welcome to this explainer. Okay, let's just dive right into it. Today, we are going to completely hack the Cambridge IGCSE Physics syllabus. We are specifically focusing on syllabus code 0625. But listen, if you are studying 0651, 0652, 5054, or even 9702, do not click away. These exact same strategies absolutely apply to you too. We are going to find the back door into every single electrical circuits question you'll ever face. To really show you what I mean, I want to introduce you to two typical students. Let's call them Alex and Sam. Now, when Alex opens a past paper and sees an exam question, he instantly panics. He just brain dumps, overloading his answer with literally every raw physics fact he can remember, completely ignoring what the examiner actually wants. His paper is usually covered in red ink. Then we have Sam. Sam's problem is that he rushes. He skims the question, completely misses the crucial command words, and just throws away easy marks, despite the fact that he actually knows the physics. Today, we're going to fix both of these flawed habits. I'm going to show you how to transform those red marks into perfect green check marks by decoding the exact structural expectations that examiners use to test electric circuits.
So, here's our blueprint for the day. 1. Decoding exam command words. 2. Mastering circuit components. 3. Parallel circuit calculations. 4. Bypassing those sneaky examiner misconceptions. And 5. Electrical safety and fuses. We have got a lot of high-yield ground to cover, so let's get into it. Section 1. Decoding exam command words. We're cracking the examiner's code. First things first, we've got to realize a really harsh truth about the exam. Getting top marks isn't just about knowing your physics. You could memorize the entire textbook front to back, but if you don't answer the specific prompt, you get absolutely nothing. 0. Top marks are about cracking the assessment objectives and decoding exactly what the examiner wants you to do.
Let's look at the command word determine. Cambridge defines this as establishing an answer using the information available. This is where you cannot be like Sam. When a question asks you to determine a value, like, say, the current in a thermistor circuit, as the temperature goes up, you aren't just guessing. You have to systematically establish the answer. You grab the data they give you, pull the right equations from your mental toolkit, and explicitly show the logical stepping stones to your final answer. If you just write down the final number, boom, you lose all the method marks.
Now, conversely, let's look at state. The syllabus defines this as expressing in clear terms. This right here is where Alex always messes up. He sees the word state and writes a massive, time-consuming half-page paragraph. Guys, if you see the word state, do not waste your precious exam time writing an essay. Just deliver the raw fact, the number, or the name, clear and simple. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Seriously, do it and let's secure those marks. Remember, for a state question, it's just one sentence, sometimes even just one word. Mark secured and you move right along. All right, in stark contrast, we have explain. This is the big boss of the exam. This is the high-value command word. The definition is intense. Set out purposes or reasons, make the relationships between things evident, provide why or how, and support with relevant evidence. To beat this, you need a solid framework. Let's call it the PEAL framework. That stands for point, evidence, explanation, link. You state your point, provide the physical evidence, explain the mechanism, and link it back to the scenario. Top students always use a structure like this for explain questions. Think about your recent past paper practice. Did you actually follow a logical structure like that, or did you just list random facts and hope for the best? Section 2. Mastering circuit components. This is the visual vocabulary of physics. Now, we're going to take this strategy and apply it to the actual visual language of the exam. Because think about it, if you can't read the map, you can't navigate the terrain, right? What you're seeing here is the comprehensive master list of required circuit components. You have to instantly recognize these to survive the paper. From standard resistors to complex stuff like magnetizing coils. You have to treat this like learning a second language. When you see a rectangle with a line through it, your brain shouldn't say box with a line. It needs to instantly scream fuse. When you see a rectangle with an arrow pointing diagonally through it, boom, variable resistor. You need to know these cold. Notice this really crucial visual distinction right here. On the left, we've got a standard diode. It's just a triangle pointing to a line. It only lets current flow in one direction. But look on the right. That's a light-emitting diode, an LED. What is the difference? The LED has those two tiny little outward-pointing arrows to represent the light being emitted. Students miss this all the time. If the examiner asks you to draw an LED and you forget those two tiny arrows, you lose the mark. It is a super harsh penalty for a small omission, but that is exactly how the coding of this exam works. So, let's pause and do a quick mental check. I'm going to give you a 60-second mental challenge. Think like an examiner for a second. If you get a question asking you to explain how a variable resistor actually alters the current flowing in a circuit, how do you describe the internal mechanics? If you're like Alex, you'd probably just write, it changes the resistance. 0 marks. That's just a statement. It's not an explanation. So how do we rewrite that and transform it into a green checkmark? We dive into the mechanics. A variable resistor has a track of resistive wire. The winning answer is explaining that a sliding contact moves over this resistive track. The current enters at one end and has to flow through the track to reach the contact. By moving that slider, you are literally changing the physical length of the track the current has to travel through. More track means more resistance, which drops the current. That is a complete, well-reasoned explanation that guarantees the mark.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get back to it. Section 3, Parallel Circuit Calculations, Solving the Resistance Puzzle.
We're going to dissect the mathematical framework of parallel circuits. The source material uses this brilliant metaphor of cars at a junction to explain a massive rule of the universe. Just like energy, electric charge is fundamentally conserved. Electrons don't just magically appear out of thin air, and they don't vanish. Imagine cars pulling up to a junction in the road. The number of cars leaving that junction absolutely must equal the number of cars that arrived. If they didn't, we'd have a huge problem. So the total current entering a parallel junction must exactly equal the total current leaving it. This is your guiding principle for every single calculation.
All right, time for our data scan challenge. Look at these steps. When you're asked to determine the effective resistance in parallel, you have to flawlessly execute these 4 sequential steps. Step 1, identify the parallel branches. Step 2, use the exact equation. 1 over the total resistance equals 1 over R1 plus 1 over R2. Step 3, find the lowest common denominator. And step 4, this is where 50% of students completely fail. You must invert the final fraction to find the total R. Let's look at this in action.
Let's look at this worked example and move to our next challenge. Find the flaw. We've got a 10 ohm and a 30 ohm resistor in parallel. Step 2, we set it up. 1 over R equals 1 over 10 plus 1 over 30. We find the common denominator of 30, making it 3 over 30 plus 1 over 30, which gives us 4 over 30. Now where is the flaw? A rushing student like Sam will just write resistance equals 4 over 30 ohms and move on to the next page. The flaw is forgetting step 4. You have to invert it. R over 1 equals 30 over 4, giving a final resistance of 7.5 ohms. And here's a massive cheat code for your exams. The combined resistance in a parallel circuit is always smaller than the smallest individual resistor. If your total is higher, you know for sure you've messed up the math somewhere.
Section 4, Bypassing Common Misconceptions. We need to avoid the examiner's traps. Examiners explicitly love to use these misconceptions as traps, especially in the multiple choice section. Here is a classic one. The misconception is that current gets used up as it travels through lamps and resistors. People think the current leaving a bulb is somehow less than the current going into it. Completely false. Like we just talked about with the car junction, charge is conserved. The reality is that the battery is literally just a pump. It just pushes the electrons that are already sitting inside the wires. It doesn't manufacture new ones, and the components definitely don't eat them. Let's do a quick speed writing mental challenge on this. Think about how you would explain this concept under a timer. Our source provides an incredibly surprising fact to refute this whole idea. Think about your phone. Most people assume that charging a phone means pumping new electrons into the battery. But if charging actually meant transferring billions of new electrons into your device, you would get a massive electric shock the second you picked it up. What you're actually doing is transferring energy. The battery is acting like a chemical pump for the charges already inside it. Pretty wild, right?
Section 5, Electrical Safety and Fuses. Explaining the fail-safes. Let's bring all this strategy together to build our final answering system.
Look at this actual exam prompt. Explain how a fuse works for 2 marks. Remember our command word training from earlier? Because it says explain, a simple one-word answer gets you 0. If you just write, it stops fires, you completely fail the question. You need the physics mechanism. You need the why and the how. To get those marks, you need to use our framework and build a logical narrative. First, point out that the fuse is connected to the live wire. Next, provide the evidence. Note that when the current exceeds the specific rating, the internal fuse wire, which has high resistance and a low melting point, heats up and melts. Finally, conclude and link it all together. This deliberately breaks the circuit, stopping the current and preventing a fire. That is a perfect hacker-level answer. And this brings us to our final, complete physics answering system. 3 rules for top marks. Rule 1, command word decoding. Rule 2, framework application. And Rule 3, time management. Don't waste 5 minutes on a 1-mark state question.
So, as you go back and review your past papers, I want you to ask yourself, which command word is currently costing you the most marks? Is it the math-heavy determine or the logic-heavy explain? Use this blueprint to fix it. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.